Greetings and welcome to the Plsql channel, a series of video trainings on the Oracle Plsql language. My name is Stephen Feuerstein, and I'm a Plsql developer just like you. This lesson is a part of my series on writing Dynamic SQL in the Oracle Plsql language, and the focus of this lesson is on executing dynamic Plsql blocks of code. Some quick reminders. First of all, if you haven't already done so, visit Plsql Obsession, toadworld.com/sf. You'll find lots of resources for Plsql developers, most importantly in terms of this video. You can download my demo zip file that contains all the files that I'll be running in this lesson, and click on Training Seminars and Presentations to download PowerPoints that support this lesson and many of my other trainings. Make sure you're comfortable with the material covered in the previous lessons in this series. Dynamic PLSQL is not the most basic feature of Dynamic SQL, so make sure you've gone through the introduction and overview, gone through the basic concepts, the ideas of bind variables, executing dynamic DDL, DML, and queries, and then I think you'll be in good shape to tackle Dynamic PLSQL. So first of all, how can Dynamic PLSQL be of benefit? I bet there's a really good chance that you have run dynamic SQL statements, dynamic queries, dynamic updates, etc., but maybe never actually executed dynamic PLSQL, a block of code. So consider the code on the right. This is from a real-world experience that I had years ago in an insurance company in Chicago. So this program was basically written over a long period of time to process different line items. For an insurance policy, they'll have different clauses that essentially escape the insurance company from having to make payments, claims, or minimize the amount of payments. And every time they came up with a different line item or rule, it was expressed in a different process line procedure, process line 1, line 2, line 3. And then whenever they ran their job to process a claim, it would run each of the different line items. And this body of code over a period of years had grown to something like 20,000 lines long. That's how many different line items they had to process. And every time they had a new line item, they would add a new clause over and over and over again. Now this is a long time ago, so it was back on Oracle 8, I believe. And so there were limitations on the size of the code, and they were concerned about it actually getting too big to compile. And in any case, it was taking a really long time to compile. So the maintenance on this program was a total nightmare. And they said to me, Stephen, can you help me? Is there a way that we can address the problem in this code? And I've got to say it was a really nice moment, because for DBAs and consultants who do database administration, it's not that hard to be a hero. Oh, you need to make your database run faster? Here, we'll put on an index, and suddenly everything's better. In the context of PLSQL, if you can improve performance by 10%, you're amazing. If you can reduce your code volume by 5%, you're amazing. But in this case, I was able to do so much more. Now, first of all, before I show you the solution, what I did, let's do a little bit of code analysis. First of all, notice that we have these if clauses, if after if after if. This, of course, is a really bad idea all by itself. If the line item is 1, it's not going to be 2 or 3 or 4 or anything else. So here's a situation where I had mutually exclusive clauses, but they were expressed in a series of if statements. At a minimum, this should be else ifs or a case statement. But I could do way better than that, and I could do way better because I noticed a pattern. We had the process line prefix and then the line number over and over and over again. And whenever you see a pattern, a repetition in your code, you should automatically think about dynamic SQL or reusable code. Now, this is one reusable program, process line item, that passes in the line number, so that doesn't help us. But maybe dynamic SQL. And that's in fact how things ended up, and it was a really wonderful moment. I took their 22,000 lines of code and brought it down to something like 10. So I took the pattern and expressed it in my code in a dynamic PLSQL block. So process line item became nothing more than execute immediate, and then I constructed my PLSQL block in which I call process line, concatenate the line number, and wow, that's it. All that code goes away, and when a new line item is added, all they have to do is create the process line 26,074 program, and this driver will not have to change at all. So I thought this was a great example to lead in on this lesson of how dynamic PLSQL can have an enormous impact on either the quality of code, the maintainability of code, and even the performance. In this case, the performance when I execute line 1 or 2 might not be better than this, though there's not a lot of overhead in simply parsing a small block like this. Whoops, let's turn that off. But when I get to line 22,000, almost certainly the cost of going through all these different rows, all these different line items and if clauses is going to be slower than simply executing the block of code. And before I continue, let's just turn off my Skype so we don't get interrupted anymore. My apologies for that. Okay, so there's a great example of how dynamic PL/SQL can have an enormous impact on your code. Let's explore further. So dynamic SQL possibilities. First of all, what can you do with dynamic PL/SQL? Well, you can do just about anything. Think about it. With dynamic SQL, you're constructing an SQL statement on the fly, so you're restricted to what SQL statements there are. With dynamic PL/SQL, you construct and execute a block of code on the fly, so you can construct entire applications dynamically. So what have I done? Well, I've reduced code volume, improved maintainability. That's the example I just showed you. I've written some very generic utilities, for example, a generic string parsing engine that will parse any string and deposit it into your own collection. I'm going to demonstrate what I'm talking about there later in this lesson. I've implemented support for indirect referencing. This is a feature back from Oracle Forms and SQL Forms that is really powerful. If I don't know the name of my variable until runtime, for example, the name of my package might be dynamic, therefore the name of my variable or function inside the package is also dynamic, then I want to be able to construct the name at runtime and retrieve the value and change it. That's not supported directly in PL/SQL, but you can do it with dynamic PL/SQL, and I'll give you a flavor of that code in just a moment. More generally, you can soft code business rules in your application. So take the code, the rules, put them in a table, construct and execute them on the fly. Not very difficult to do, of course, depending on the complexity of your rules and how many values are going in and coming out and so on. And we'll talk about some of the details of that. But you can pretty much do whatever you want with dynamic PL/SQL. Now, in this lesson, what I'm going to do is go over the basic rules, how to go about writing dynamic PL/SQL code, some of the issues you might run into, and I'll go through the steps that I think you should follow to construct your dynamic PL/SQL implementations. Before I do that, I had mentioned the support for indirect referencing. If you ever have a situation like this, so you need to actually get the value of a variable or change the value of a variable, and the variable name is not set until runtime, check out the dynvar package. So the dynvar package says assign this expression to that variable passed as an in-out. Get the value of a named variable. Copy a value to a named variable. So I'm not going to go through all the details of this. I'll be showing you examples of all this kind of code later on as I get into the details of it. But you might try it out and see what you think. And again, if you ever run into any requirements that involve constructing the name of your variable at runtime, that's the package to use. Okay, so let's get into the details. What is involved in writing dynamic PL/SQL? Well, first of all, generally speaking, what it comes down to is you're dynamically constructing, compiling, and running an anonymous block with execute immediate. Now, you could also do it with DBMS SQL, no question about it, but I don't see any reason to do that. At this point, you should always use execute immediate for dynamic PL/SQL. Much easier to write and faster. So you're constructing and running anonymous blocks. And you'll use the using clause just as you would with dynamic DML, updates, inserts, deletes, to pass values in and also to get values out of your PL/SQL block. I had talked in the Method 2 Dynamic SQL lesson about bind variables and how they have modes in, out, and in, out. And generally speaking with DML, you're only using ins, but with PL/SQL, it's very common that you will use outs and in-outs. And you don't use the into clause with dynamic PL/SQL. That's only for Dynamic SQL Method 3 or execution of queries, fetching data into. So you'll only use the using clause at most, and not the into clause. Some rules for writing and running dynamic PL/SQL. The block that you execute has to be a valid anonymous block. It has to start with begin or declare, and it has to end with end semicolon. And again, that block must end with a semicolon. Otherwise, it is parsed as an SQL statement. Many people who've been around Oracle for a long time think that SQL statements end with semicolons because that was the SQL Plus default character to specify execution of the buffer. But in dynamic PLSQL, Oracle is more strict. A semicolon only terminates PL/SQL blocks and not SQL statements. And you can only reference directly program elements that are accessible at the schema level. In other words, local variables cannot be directly accessed inside a dynamic PL/SQL block. All right, let's take a look at some examples. First of all, my Dynamic SQL driver. Here's a little exec dynamic PL/SQL just to use for my demonstrations. I'm going to pass in a block. I'm going to ask whether or not I want to trace, whether or not I want to re-raise the error. The block is passed in, and then I construct a valid PL/SQL block from it. So in case somebody forgot to put it inside begin ends, I'm going to make sure that it starts with begin, ends with a semicolon, and then has an end statement. I can display the block if I choose to, and then simply execute it. And here I'm assuming that there are no bind variables. We'll come back to the using clause and bind variables in a moment. So this is a very simple case. Construct a block of code, execute it. And if something goes wrong, I'll display the error message and the code. So that's a very basic example and a little utility for running dynamic PL/SQL. Let's take a look at the no local script. So what I'm going to do is run through a variety of efforts to change a value of a local variable or a global variable. So first of all, here's my local variable. I'm going to construct a block of code that does an assignment of ABC to my local variable. Now, I don't have to put it inside begin ends because my driver will do it for me, my little utility, but let's do it to make sure you see that it has to be a valid begin end block. So there's my assignment, ABC to local variable. Local variable is defined right there. I do want to turn on tracing. I don't want to re-raise the exception. If it occurs, it'll just display a message. Let's try this. Looks reasonable. There's the variable. There's the variable. Run my code. And here's what I see. Dynamic PL/SQL error. Identifier local var must be declared. So the thing to recognize here is that even though I'm constructing this block of code and it's seeming to execute it inside the scope of this block is actually executed at the schema level outside of the scope of this local block, of this anonymous block. Local variable cannot be directly referenced from within my PL/SQL block. It's not known. That's what this message is saying. In addition, notice that my block looks kind of strange. That's the trace of the block. Begin, begin, end, end. Well, it does look kind of strange, but it doesn't hurt anything. In other words, remember my little utility always puts a begin end around whatever block is sent in just to make sure that the begin end is always there. If not, you might run into problems. So you'll see the double begins, double ends. It doesn't matter. And of course, usually in your code, that won't happen. But in fact, let's see what happens if I don't use begin end. Let's do an execute immediate. Let's grab this right here. Come back here and try to execute immediate my assignment without begin end. I run this and I get invalid SQL statement. Since my piece of code did not start with declare or begin, it's not even trying to recognize it as dynamic PL/SQL. And it says, well, you've got an invalid SQL statement. That's just garbage. So you always need to have begin end or declare begin end if you're declaring variables inside your block of code. So I couldn't change the value of my local variable. What kind of values can I change? Let's try this again. And what I'm going to do now is to create a package called global variables. And I'll declare a string at the package level, a variable called string, assign it the value of same old thing. A package or any stored program unit can be called from or is accessible from the SQL layer at the schema level. So this time what I'm going to do is see, let's change this to dbms output just to keep things simple. So what I'm going to do now is check the value of my global variables string before. Then I'm going to execute my dynamic PL/SQL block assigning the value of amazing to my string and then display it after. Run my code. Let's get rid of all this other stuff. Run my code, and here's what I see. Before, same old thing. Run this piece of code that assigns a value to this variable, and then afterwards the value is changed. So because the package is available for execution and reference from within anywhere in my schema, and I'm running this block of code at the schema level, I can reference my global variables .string. I can also call functions, procedures, etc. But they have to be recognized at the schema level. They have to be something you can call inside or through Dynamic SQL. Moving on. Dynamic PL/SQL and bind variables. So just as with Dynamic SQL, you can use the using clause to replace placeholders with variable values. The big difference from Dynamic SQL include two things. First of all, with Dynamic PL/SQL, you'll find yourself often utilizing out and in-out modes for your bind variables, because if your procedure that you're calling dynamically has an out argument, you need to get that out. And also you might be grabbing or assigning a value to a variable and simply retrieving the value of that variable. Also, with Dynamic PL/SQL, if you reference the same bind variable name more than once inside as a placeholder, then you only specify it once in the using clause. So if you have multiple placeholders with the same name with Dynamic PL/SQL, you do not supply a value multiple times, which is exactly the opposite of Dynamic SQL. Let's take a look at all